Welcome guys to this another video. In today's video we'll be looking at the Taylor series expansion, but before we get into the video guys, don't forget to subscribe to the channel, give this video a thumbs up and hit that notification bell to be notified whenever we post new videos. Now this video was requested by two of our viewers from our MacLaurin series expansion video, so if you haven't got a chance to see that video as yet, I'll have the link to that in the description section of this video, and I'll also have it pinned to the comment section of this video as well. So let's get right into this video guys. What is the Taylor series expansion? Now the Taylor series is an expansion of some function into an infinite sum of terms. Now based on the nature of the function guys, the Taylor series can be used to find the cube root of a number, the square root of a number, etc. So we can have Taylor series expansion for even trig functions, and I'll have an example of that in this video as well. Now the Taylor series expansion formula is f of x is equal to f of a over 0 factorial plus x minus a in bracket times the first differential of f of a over 1 factorial plus x minus a in bracket raised to the second power times the second differential of f of a over 2 factorial. And by now you get the sequence guys, or the pattern for the Taylor series expansion formula. The next one would have been x minus a in bracket raised to the third power times the third derivative of f of a over 3 factorial. And we can have an infinite sum of terms guys. So that's why we have the three dots here to show that it continues. And the thing about the Taylor series expansion guys, the more term we have, the more accurate the series will be. Especially let's say we want to find the square root of a number. The more terms we have is the more accurate the result will be. And you'll see that in our first example right here. So here we have question 1. Determine the first three terms of the Taylor series expansion of f of x is equal to the square root of x, and use the series to calculate the square root of 10. Now, we have to bear in mind that we want to use a series to calculate the square root of 10. Now, the first thing that we want to look at, guys, is our function. By having the function here, we'll know what we need to find in order to write out the first three terms of the Taylor series expansion for the function f of x is equal to the square root of x, bearing in mind that we want to use a series to calculate the square root of 10. And you'll find out soon guys, it's quite easy, nothing really to it. So here we have the formula again guys. Now we're going to need our f of a, the first differential of f of a, and the third differential of f of a. So these are the first three terms right here. So we're going to need these values. Now the key thing here guys, before we go on and differentiate, we're going to need a value for f of a, not just the function. So the key thing here guys is to find out what is our a value, or how do we choose our a value if we're not given the a value in the problem. Now bearing in mind the a value is dependent on the function and what we want to use the series to calculate. Now the function is f of x is equal to the square root of x. We want to use the series to calculate the square root of 10. Now we want to find the closest perfect square to 10, because 10 is not a perfect square, meaning that if we should square root 10, we'll not get a whole number for the answer, we'll get a decimal value. So we want to find the closest perfect square to 10. Which number is closest to 10 that we can find the square root of, and the result will be a whole number. There you go. That number will be 9. And that is how we choose our a value. Alright. Now after choosing the a value guys, we can go ahead. We are going to find f of a, the first differential of f of a and the second differential of f of a, because we are going to need these values for our first three terms. Alright. So we're going to go ahead and find our f of a. So our f of a, bear in mind that f of x is equal to the square root of x. So therefore f of a will be equal to the square root of a. Remember guys, that way we have outlined that our a value is 9. So therefore we can say f of a is equal to the square root our a value is 9, square root of 9. Square root of 9 is of course 3. And that's pretty much how we find our f of a. And this is our f of a, 3. I'm going to have this value here, guys, because we're probably going to have to erase this section of the board to get some more space. So I'm going to write it up here. So f of a is equal to 3. Now I want to find the first differential of f of a. First differential of f of a, which means we are going to have to differentiate the f of a function. Now, bear in mind, guys, that the square root of a is the same thing as a raised to the power of a half. Alright? So let me put that out here just in case you're struggling to picture that in your mind. So f of a is equal to a raised to the power of a half. Same thing as a, the square root of a. Alright, so the reason why I write it like this, guys, because we're going to differentiate this, and it's probably easier to differentiate this than to look at the square root sign right here. So being that we know that the square root of a is the same thing as a raised to the power of a half, we can differentiate the function a raised to the power of a half. Now we're going to differentiate this using the power rule, so we're going to multiply by the power, then we're going to subtract 1 from the power. So in multiplying by the power, we'll end up with what? A half times a. We'll subtract 1 from the power. A half minus 1 is of course negative 1 over 2. And we can clean this up a little bit, guys. Alright, can clean this up. So we have f of a is equal to, and this is the same thing, of course, 1 times a raised to the power of negative a half is a raised to the power of negative a half, and we'll have the 2 in the denominator here. We can even go a step further and clean this up using the laws of indices here. So this is the same thing as 1 over 2, and in bracket we can have the square root of a. So we use the law of indices there to write it in a form so that we can plug in our a value, and it's probably easier to use. Alright, so we'll have 1 over 2, and in bracket we'll have the square root of 9, and this will be equal to 1 over, let's see, the square root of 9 is of course 3. 2 times 3 is 6. So therefore the first differential of f of a is equal to 1 over 6, and I'm going to write that here. So the first differential of f of a is equal to 1 over 6. Alright, and we are going to continue. So we need to find second differential of f of a, and to do this we're going to need the first differential of f of a function, and we can use this one here. We're going to use this one. Alright, so we're going to multiply by the power, so we'll have negative 1 over 2 times, we have a raised to the power of negative a half here over 2. Remember, guys, we're going to take 1 from the power. If we take 1 from the power, we'll have minus a half minus 1, which will give us negative 3 over 2. And of course, guys, we can clean this up a little bit. So we have second differential of f of a is equal to, we can multiply this out, so we'll have negative 1 times a is of course negative a raised to the power of negative 3 over 2 over 2 times 2 is 4. And here we can go a step further using again laws of indices to our benefit. So we'll have negative 1 over 4, and in bracket here we'll have the square root of a in bracket cube. And remember, guys, our a value is 9, so can replace our a with 9. So we have 4 bracket square root of 9, and we're going to cube it. And let's see what this gives us. So we'll have negative 1 over the square root of 9 is of course 3. 3 cube is 27, and of course 4 times 27 is 108. So therefore the second differential of f of a will give us negative 1 over 108. So the second differential of a is equal to negative 1 over 108. And that is pretty much majority of the work, guys. So I'm going to clear this space so we can write out the first 3 expansion. Now to write out the first 3 expansion, guys, we're going to need these 3 values that we just found, and we're also going to follow the formula here. So we're going to have our f of x is equal to f of a. Of course, f of a, we found that to be 3 over 0 factorial, which is 1, plus we're going to have the first differential of f of a times the bracket here, which is x minus a. Recall, guys, that our a value is 9, so we can replace a in the bracket here with 9, which is what we're going to do. So it doesn't really matter, the order of multiplication doesn't really matter here. So we could have had the first differential of f of a at the front, which is how we are going to write it. So the first differential of f of a is 1/6. So we'll have 1/6 times the bracket here, which is x minus a, and again our a value is 9, over 1 factorial, which is 1, plus we're going to put the value for our second differential at the front again, just like we did the first differential value. So we're going to put our negative 1 over 108 at the front, times the bracket here, x minus a, and again our a value is 9, and we're going to raise this to the second power just the same, over 2 factorial, which is of course 2. And these are the first 3 terms, guys, and all we need to do here is just to clean this up a little bit. So f of x is equal to 3 divided by 1 is of course 3, plus 1 times the bracket here, bracket will remain x minus 9, over 6 times 1, which is 6. And whenever we have a positive and a negative sign like this, it's always equivalent to a negative sign. 1 times the bracket here, raised to the power of 2, will remain x minus 9 in bracket, raised to the second power, over 108 times 2, which is 216. And these are the first 3 terms of the Taylor series expansion of f of x is equal to the square root of x. And we'll bear in mind that we want to use a series to calculate the square root of 10, which is what we are going to do next. Now let us erase this space and use this series to calculate the square root of 10. Now we want to use the series that we just found, guys, to calculate the square root of 10. Now recall the series. So there we go. F of x is equal to 3 plus x minus 9 in bracket all over 6 minus x minus 9 in bracket squared over 216. So I want to use this series to calculate the square root of 10. Remember, guys, that these first 3 terms, they are Taylor series expansion for the function f of x is equal to the square root of x, and we use our a value with respect to the 10 right here. So they should give us a close value to the actual square root of 10. The reason why I say a close value and not the exact value is because we only wrote out the first 3 terms. The more terms you have, the more accurate your answer will be. But we should get a very, very close value. But before we use the series, guys, to calculate the square root of 10, let us first use our calculator to find out what is the actual value for the square root of 10. Now, according to the calculator, the square root of 10 is equal to 3.162277766. So that's a value that the calculator gives us, and we're saying that we won't get that exact value, but we should be getting something very, very close. All right. So let us go ahead and see if the Taylor series expansion actually works. So here we have f of 10. So our x value would be 10 here because this series is an expansion of the function f of x is equal to the square root of x. All right. So we can use it to find square root. And remember, we use a value, bearing in mind that we want to find the square root of 10. So our a value was 9, which is a perfect square and the closest perfect square to 10. So we have f of 10 is equal to 3. So wherever we have x, we'll replace the x with 10. So we'll have 10 minus 9 over 6. We have a minus sign here. We have 10 minus 9 squared over 216. And let's simplify this and see what we get. So we have f of 10 is equal to 3 plus 10 minus 9 is of course 1, so that's 1 over 6 minus 10 minus 9, again that's 1, 1 squared is 1, so we have 1 over 216. And let's see what this gives us, guys. Again, you can work this out, you can convert these to decimals, but of course if you have a good calculator, you can plug in these values and the calculator will do the work for you. Now when I plug this into my calculator, guys, I got 3.16237, which is pretty close to the actual values, right? So I actually got the first 3 decimal places, right? But of course, as we mentioned before, it won't be as accurate because we just found the first 3 terms. All right, so the more terms you find, the more accurate the answer will be. So therefore, the Taylor series expansion, as we can see here, is pretty cool. All right, so let us look at question 2. Now, question 2 asks us to determine the first 3 terms of the Taylor series expansion of f of x is equal to the cube root of x. And I want to use the series to calculate the cube root of 10. All right, so the first one we looked at was, of course, the square root. It was a function f of x is equal to the square root of x. Now, we want to find Taylor series expansion of the function f of x is equal to the cube root of x. And we have to bear in mind, guys, that we want to use a series to calculate the cube root of 10. And again, we want to start off by looking at our formula for the Taylor series expansion. Here's our formula. By now, you'll be familiar with it. And again, guys, we're going to need our a value. Bear in mind that the a value is dependent on the function that we want to write Taylor series expansion for, as well as what we want to use it to calculate. We want to use it to calculate the cube root of 10. All right. And of course, the function is f of x is equal to the cube root of x. So based on what we did, guys, in question 1, what I want you guys to do for me is to let me know in the comment section, what do you think the a value will be? So you can write it like a is equal to whatever you think that number will be. And let's see how many of you guys will actually get it correct. You can pause the video if you need more time to think about it before I actually give you the a value. Alright, now that you guys are back, I hope many of you guys got it correct. So our a value for this particular problem will be 8. Alright, and again, the reason 8 is the closest value to 10 that when we find the cube root of this number, we'll get a whole number as the result. Bear in mind that when we find the cube root of 10, of course, we'll get a decimal value. Now let's get right down to business. This also asks us for the first 3 terms, so we know that we're going to need our f of a, first differential of f of a, and also the second differential of f of a. So we're going to go ahead and find our f of a. And of course, guys, being that f of x is equal to the cube root of x, then f of a will be equal to, there you go, the cube root of a. Now, our a value is 8, so therefore, f of a will be equal to the cube root of 8. And of course, the cube root of 8 is 2, which means our f of a value, can say therefore f of a will be equal to 2. Now we're going to need to find the first differential of a. So the first differential of a, and again guys, we are going to differentiate our f of a function, and we're going to rewrite the f of a function just like question 1. So the cube root of a is the same thing as a raised to the power of 1/3. And again guys, the reason why I do this is probably easier to look at when we're thinking of differentiation than the actual cube root sign right here. So in differentiating this function, we'll multiply by the power. So we have 1/3 times a, and of course we'll minus 1 from the power. 1/3 minus 1 will of course give us negative 2/3. Alright, and of course again guys, we can clean this up. So first differential of f of a is equal to 1 times a raised to the power of negative 2/3. That is of course a to the power of negative 2/3. And we'll have the 3 in the denominator here. And we can go a step further. By now, you know, can apply the laws of indices. So we'll have 1/3. And in bracket here, we're going to have the cube root of a in bracket squared. And recall guys that our a value is 8, so we can plug that value in here. So we'll have 3 in bracket the cube root of 8 squared. And what will this give us? 1 over, let's see, the cube root of 8 is of course 2. 2 squared is 4, and of course 3 times 4 is 12. So therefore, the first differential of f of a, we can say is equal to 1/12. And now guys, we need to find the second differential of f of a. Alright, and again, we can use this function here. We're going to need the first differential of f of a function, and we're going to use this one. Now again, we'll multiply by the power guys, so we're going to have negative 2/3 times, we have a raised to the power of negative 2/3 here over 3. And recall that we'll minus 1 from the power, so negative 2/3 minus 1, that will give us negative 5/3. Alright, and again guys, we can clean this up a little bit. So I have the second differential of f of a is equal to, and of course negative 2 times a raised to the power of negative 5/3 will of course give us negative 2a raised to the power of negative 5/3 all over 3 times 3 is of course 9. And where do we go from here? Of course guys, we can clean this up a bit more using the law of indices, so it's probably easier to work with. So here we'll have negative 2 over 9, and in bracket here we'll have the cube root of a raised to the power of 5, and this will be equal to negative 2 over 9 in bracket the cube root of 8, because our a value is 8, raised to the power of 5. And what will this give us? We'll have negative 2 over the cube root of 8 is of course 2. 2 raised to the power of 5 is 32, and of course 9 times 32 will give us 288. And of course we can reduce this guys, so 2 into itself 1, 2 into 288 will give us 144. So therefore we can say the second differential of f of a is equal to negative 1/144. And again guys, this is majority of the work done here, so we're going to clear this space again, and then write out the first three terms. Now to write out the first three terms, guys, we're going to use the Taylor series expansion formula to guide us. So we're going to have f of x is equal to the value that we got for f of a was of course 2. We'll have this over 0 factorial, which is 1, plus we're going to multiply this bracket here by the value that we got for the first differential of f of a, which was 1 over 12. So 1 over 12 times the bracket here, x minus a, and of course the value for a is 8 over 1 factorial, which is 1, plus we're going to multiply this bracket here, x minus a all squared, by the value that we got for the second differential of f of a, which was negative 1 over 144, and we'll multiply this by the bracket here, so we'll have x minus, and of course guys the value for a is of course 8, and raise this to the second power, and we'll put this over 2 factorial, which is 2. And we can always clean this up a little bit, so we have f of x is equal to 2 divided by 1 is 2, plus 1 times x minus 8 in bracket will remain x minus 8 in bracket. 12 times 1 is 12, and whenever we have a positive and a negative sign beside each other like this, they're equivalent to a minus sign. So we'll have minus, and we'll have 1 times the bracket here. Of course it will remain x minus 8 in bracket squared all over 144 times 2 is of course 288. This is pretty much the first three terms of the Taylor series expansion of the function f of x is equal to the cube root of x, guys. Now we want to use this series to calculate the cube root of 10. Now as we mentioned before, guys, we want to use the series to calculate the cube root of 10. Now recall the series. So this is a Taylor series expansion for the function f of x is equal to the cube root of x, bearing in mind that we wanted to use the series to calculate the cube root of 10. And we chose our a value as you would have seen before, bearing that in mind. So this is a function f of x is equal to 2 plus x minus 8 in bracket over 12 minus x minus 8 all squared over 288. So we're going to use this now to find the cube root of 10, and that is pretty much what this Taylor series expansion was for. So we wrote just 3, and remember guys, we can have an infinite amount of terms, but we just wrote out the first 3. So therefore again, this answer will not be the exact value for the cube root of 10. So bearing that in mind, let us go to our calculator and first find out what is the exact value for the cube root of 10. Now the value that I got from my calculator was that the cube root of 10 was 2.15443469. So that's the value that I got, guys. So let's see how close the Taylor series expansion result will be. So I want to find this cube root of 10, so I'm going to plug 10 into the series here. So we have f of 10 is equal to 2 plus, wherever we have x, we replace the x with 10. 10 minus 8 over 12 minus 10 minus 8 raised to the power of 2 over 288. Of course guys, again, can clean this up a little bit. So we have 2 plus 10 minus 8 is of course 2, so we have 2 over 12 minus 10 minus 8 is of course 2. 2 squared is 4, so we'll have 4 over 288 here. And we can plug this into our calculator and get a value. You can simplify it if you wish to, but of course you can use a calculator to do the work for you, and we can see how close our result will be toward the actual value of the cube root of 10. And the value that I get, guys, when I plug this into my calculator, got 2.1527, which again is pretty close to the actual value. So as you can see here, guys, the Taylor series is pretty is pretty cool and it works pretty well. Alright, now to look at our final example, guys, we're going to look at a trig function. Now we're looking at question 3. Determine the first four terms of the Taylor series expansion of f of x is equal to sine of x. And here they gave us the a value, which is pi over 6. And as always, guys, we always want to have our formula here to guide us throughout the entire process. Now here we have our formula, guys, and unlike the previous examples, they want us to find the first four terms, which means we are going to need to find f of a, the first differential of f of a, the second differential of f of a, and also the third differential of f of a. So the concept remains the same. Bear in mind also, guys, that a here, pi over 6 is the same thing as 30 degrees. I think you guys probably know how to convert from radians to degrees. All right, we're going to use the formula to guide us, of course. So we're going to need to find our f of a, and of course, if f of x is equal to sine of x, then f of a will be equal to sine of a. So therefore f of a will be equal to sine of 30 degrees, which you can find in your calculator quite easily. And of course, sine 30 is a half. Next step is to find the first differential of f of a. Of course, when we differentiate sine a, we'll get cos a. So therefore, the first differential of f of a will be equal to cos of 30 degrees, which is of course root 3 over 2. Next, we'll find the second differential of f of a. When we differentiate cos a, we'll end up with minus sine a, which means the second differential of f of a will be equal to minus sine of 30 degrees, which is equal to negative a half. And finally, guys, we'll find the third differential of f of a. And of course, when we differentiate minus sine a, we'll end up with minus cos a, which means the third differential of f of a will be equal to minus cos of 30 degrees, which is minus root 3 over 2. And these are our values, guys, that we need in order to write out the first four terms. And we can have them here as well, since I'm going to have to erase down here. So f of a is a half. First differential of f of a is root 3 over 2. Second differential of f of a is minus a half. And of course, the third differential of f of a is minus root 3 over 2. Now we're going to erase this space and then write out the first four terms. Now our final step is just to write out our first four terms, which we can do with the aid of our formula here. So we'll have f of x is equal to our f of a value, which was a half. So we'll have half divided by 0 factorial, which is 1. A half divided by 1 is still a half, plus we'll multiply this bracket here, x minus a in bracket, by the value that we got for the first differential of f of a, which was root 3 over 2. So we'll have root 3 over 2 times the bracket here, x minus a, and we'll just replace a with the a value that they gave us, pi over 6. Of course, this is the same thing as 30 degrees, but we'll just use back the value that they gave us. We'll put it back in radian form, and we'll put this over 1 factorial, which is 1, plus, again, we'll multiply this bracket here, x minus a in bracket all squared, by the value that we got for the second differential for f of a, which was minus 1 over 2, minus a half. So minus a half times x minus, again, the value for a is pi over 6, and we'll square the bracket just the same, and we'll put this over 2 factorial, which is 2, plus we'll multiply this bracket here, x minus a all cubed, by the value that we got for the third differential of f of a, which was minus root 3 over 2. So we'll have minus root 3 over 2 times x minus a, and again our a value is pi over 6, and we'll cube the bracket just the same, and we'll put this over 3 factorial, which is of course 6. And of course guys, we can clean this up a little bit, as I always like to say, so it look a whole lot more presentable. So let's keep the half here, plus of course we have root 3 times the bracket here, so root 3 times x minus pi over 6 in bracket. And of course, once we have an addition and a minus sign here, the combination of both signs is always equivalent to a minus sign. So we'll have minus, of course, 2 times 2 is 4. So we can have a quarter here times this bracket here, which is x minus pi over 6 all squared. And again, combination of a positive and a negative sign is always equivalent to a negative. So we'll have minus root 3 over 2 times 6 is of course 12, so root 3 over 12 times this bracket here, which is x minus pi over 6 all cubed. And that is it for this video guys. I hope this video was beneficial to you. As I said before, this video was requested by 2 of our viewers, and I'm sure others out there would have desired this video just the same. So I hope the 3 examples that we use in the video was appropriate and it was very helpful. Let me know in the comment section as well if you found this video helpful. Was it beneficial to you? Let us know in the comment section below. So that's it guys, and don't forget to subscribe to the channel if you haven't yet done it. Give this video a thumbs up and hit that notification bell to be notified whenever we post new videos. Until next time, blessings and peace to you all.